Hey, I'm Sean Morris, president of Schima. Real quick video for you today. I'm just going to go through and discuss the difference between watt hours and amp hours and why we prefer to use watt hours and why I think you should use watt hours when you're making a decision about batteries. All right. On our website, we've got a lot of products and I'd prefer to talk about them in watts. When we get into conversations with customers or I'm trying to lease or rent a product to a customer, they often ask about amp hours. Amp hours isn't the way to go when we're dealing with batteries. So an amp hour doesn't take into account the voltage of the battery. So if you've got an appliance like this projector right here, this projector on the bottom has a label that says that it is 110 voltage, 110 watts. Okay, that wattage is a rating of the power that this is going to draw per hour. Okay. It took into account the voltage, and with a little formula, you get what the power draw of this actually is. And that same formula can be used with the batteries. So if you looked at this battery, for instance, this battery says it's a 5,000 milliamp hour battery, 5,000 milliamps. This battery is also a 5,000 milliamp battery. So these both are about the same milliamp hours, but the wattage is completely different. This is a 111 watt hour battery, and this one's a 57 watt hour battery. Completely different. And I mean, you can tell by the size, right? So the completely different capacity, and the difference is the voltage. Now the amp hours isn't going to take that into account. These have the exact same number of amp hours. So that's not really going to tell you what the capacity of the battery is. But knowing the watt hours, you have an idea of the capacity of that battery. And that's really specifically important when you're using something like this blue box right here. This is our 4-port inverter. This 4-port inverter takes our DC energy and changes it to AC to power a load, right? So we connected our 24-volt battery, that's 2.5 kilowatt hours, to this 4 kilowatt inverter, and we run the AC out to that sign down there. When we turn this all on, the sign lights up. If I only know the amp hours of my load, I don't have an accurate picture of what the load's gonna be on my batteries. If I know the watts that sign draws, then I have a more accurate idea of how long I can run that. I can divide the watt hours of the battery by the watts that sign is going to draw, and I know how many hours I'm going to be able to run that sign. You wouldn't be able to do that normally with amp hours because we're converting all of that DC energy into AC energy to use to run our load. So it's a really simple little bit of math. Most things do list the watt hours. So this is another little battery right here. It's a 2200 milliamp hour, 11.1 volts, and then it says on there that it's 24 watt hours. Here's another example. This battery doesn't say watt hours. It says 8.4 volts, 4.4 amp hours. Each one of these cells in our 100 amp hour battery, this is a 100 amp hour GBS cell, lithium iron phosphate. Each one of these cells has 320 watt hours of capacity. And these are in series, so they just stack. And when you have 2 4-packs, you wind up with 2.5 kilowatt hours of capacity, which is what our Schima Seahorse case has. So when you start to make decisions about batteries, especially if you're comparing different chemistries of batteries, like you're comparing a lithium iron phosphate to a lead acid battery, those watts become really important because they've taken into account all the little facets involved with the battery so that you have a more accurate picture of what the actual power capacity of that battery is. So yeah, that's really all there is to it. Just use the watt hours, look at the watt hours. But thanks for watching. Give us a like and a subscribe, I appreciate it, and follow us. Thanks.